Hello all, welcome back. This is a continuation of previous video, that is AVL tree, and in this video we'll be discussing about insertion operation of AVL tree, that is how to construct an AVL tree with the given values. So these are all the examples I have taken. For this, how do we construct an AVL tree? And before going for construction, first you should understand the basics about AVL tree. So if you didn't watch the previous video, once go back, watch that and then come to this video. And in this example, so we are going to construct the AVL tree by performing insertion operation, and when the tree is unbalanced, we need to perform rotations to make it as balanced. And let's get into the topic. So first, whenever you're given with these values, okay, start inserting the values in the given order only. Okay, take the values in the given order. So first you need to insert 10 and then insert 20 and then insert 30, then 40. Okay, likewise take the values in the given order. Then based on that you have to insert one by one. Okay, and that should satisfy the binary search tree property. Also you need to make sure whether the tree is height balanced by finding the balance factor, right? So step 1, what is our step 1? Step 1 is inserting this value 10 into an empty binary search tree. So directly I am inserting value 10 into the empty binary search tree. Now after inserting 10, you need to find what? Balance factor, because you are constructing AVL tree, that is height balanced binary search tree. So we need to find the balance factor. And what is the balance factor of 10? So what is the formula for finding balance factor? Height of left subtree minus height of right subtree. So what is the height of left subtree for 10? 0. What is the height of right subtree for 10? 0. Because it is the only one node in the tree, there is no child node. So 0 minus 0 is 0. So balance factor is 0 and the tree is balanced. So don't do anything. Move to the next step. What is the next step? Insert 20. So when you are inserting 20, I told you should follow binary search tree property. So where 20 will get placed? First compare 20 with 10. 20 is greater than 10. If it is greater than 10, place it at the right hand side of 10. So 20 will be placed here. Okay. After inserting 20, again find the balance factor for these two nodes. So first starting from 20, what is the balance factor for 20? This is a leaf node. So the balance factor is 0. And what is the balance factor for 10? So what is the height of left subtree of 10? 0. And what is the height of right subtree of 10? That is 1. So 0 minus 1, the value will be minus 1. And this tree is also balanced again. So go for the next step. And in the next step, we are going to insert 30. So where 30 will get inserted? As usual, compare 30 from root node 10. 30 is greater than 10. So move towards right. Again compare it with 20. 30 is greater than 20. So move towards right. Right side it is empty. So insert 30 here to the right of 20. After insertion, what we need to do? Find the balance factor. So what is the balance factor of 30? 0. Then what is the balance factor of 20? Left side height 0 minus right side height 1. So 0 minus 1 minus 1. Then coming to 10, what is the balance factor for 10? So height of left subtree is 0. And what is the height of right subtree? 2. So 0 minus 2 minus 2. Here it is balanced, here it is balanced, but in this node it is unbalanced. If the tree is unbalanced, then we need to perform rotations to balance the tree. And check the structure of the tree. What is the structure of the tree? Here it is right skewed. If it is right skewed, like if it is left or right, whatever it is, if it is a skewed tree, you have to apply single rotation. And now in single rotation, which rotation we need to apply? Again check, it is right skewed. If it is right skewed, apply left rotation. So here we will be applying single left rotation, which is nothing but LL rotation. Okay, we are performing LL rotation. If you apply LL rotation, what happens? The root node, here the unbalanced node will move towards the left hand side. Okay, so this will move to left side of 20. Now root node value will be 20, left of root 20 will be 10 and right of 20 will be 30. Okay, so after performing rotation, this will be our final tree. But here again what you need to do, you need to find the balance factors for all these nodes. So what is the balance factor of 30? 0. Balance factor of 10? 0. What is the balance factor of 20? Again, height of left subtree minus height of right subtree. Height of left subtree is 1. Height of right subtree is 1 again. So 1 minus 1, 0. So the tree is balanced here. If the tree is balanced, so move to the next step. What is the next step? Insert the next value. What is next value to be inserted? 40. So where 40 will be inserted? Again compare 40 with 20. So 40 is greater than 20. Move towards right side. Again compare 40 with 30. 40 is greater than 30. Again move towards right side. Now 40 will get placed towards the right of 30. Okay. After placing 40, now go for balance factor. What is the balance factor for the 40? It is 0 because leaf node. Again, what is the balance factor of 10? It is 0 because leaf node. Now again coming to the balance factor of 30. What is the balance factor of 30? Height of left subtree minus height of right subtree. Height of left subtree is 0 minus height of right subtree is 1. So 0 minus 1 minus 1. Now balance factor for 20. What is the height of left subtree? 1. What is the height of right subtree? 2. So 1 minus 2, it is minus 1. 1 minus 2 minus 1. If you check here, all the balance factors are in the range. So this tree is also a balanced binary search tree. Right? So if it is balanced, go for inserting the next node. What is the next node value? 50. Again, where 50 will be inserted? Compare it with 20. It is greater, move to right side. Again, compare it with 30. Greater, move right side. Again, compare with 40. Greater, move right side. Now, right side here it is empty. So you can place 50 to the right of 40. In that case, what will be our tree structure? So 20, 10, 30, 40 and then right side will be 50. After insertion, now again check for the balance factor. Balance factor for 50 is 0 because it is a leaf node, and balance factor for 10 is also 0 because this is also a leaf node. Now what is the balance factor for 40? Okay, so left child height is 0 and right subtree height is 1. So 0 minus 1 minus 1. Now coming to 30. What is the balance factor of 30? Left side 0. Coming to right subtree, height is 2. So 0 minus 2 minus 2. Now, what is the balance factor for 20? So, left side height is 1 and right side height is 1, 2, 3. So, 1 minus 3 again minus 2. If you see here, we got two balance factors minus 2 and minus 2. So, the tree is unbalanced. But here, in order to make this tree balanced, we need to perform rotation. And which rotation we need to perform and where we have to do rotation, because there are two nodes which are having unbalanced factor minus 2 and minus 2. If you have more than one nodes having unbalanced factor, then start balancing from the lower level. Okay, start balancing from the lower levels, lower subtree, right? In that case, here we need to consider these three nodes. Okay, 30, 40 and 50. This is the lower level here and this 30 is unbalanced. So we are going to consider 30, 40 and 50 in this case. Okay, so if you take the structure 30, 40, 50. So this is what the structure. So 30, right side 40 and 50. And if you observe, this structure is a right skewed. If it is right skewed, we need to apply single left rotation. So if we apply single left rotation, that is LL rotation, then the final tree structure will be, so this 30 moves towards left side and after that we will get 40, left side is 30 and right side is 50. So after performing single left rotation, this will be the resultant tree structure for this one. Okay, so just to place this tree here in this place, right? So if you place that here, what will be the tree structure? Tree structure will be as usual 20 at the root and 10 will be the left child. Now coming to this right subtree only, we just have done rotations and we balanced it. So what will be the final structure after performing rotation on these three nodes? So 40 is a parent node and left of 40 is 30 and right of 40 is 50. Okay, so this is our tree structure after rotations. Now we try to balance this tree. Okay, so sorry, we'll try to find the balance factor for this tree and we'll see whether it is balanced or not. What is the balance factor for 50? 0 because it is leaf node. What is the balance factor for 30? It is 0 because it is leaf node. What is balance factor for 10? Again it is 0 because it is leaf node. Now coming to the balance factor for 40. So what is the height of left subtree? 1. What is the height of right subtree? 1 again. So 1 minus 1, 0. Now balance factor for 20. What is the height of left subtree? 1. Now what is the height of right subtree for 20? How many levels are there? 2 levels are there. So what is the height of right subtree? 2. 1, left subtree 1, right subtree 2. So 1 minus 2 minus 1. Now these are all the balance factors that we found for this tree. And here you can see all the nodes are balanced, okay, because all the balance factors are 0 and minus 1. So everything is balanced, right? So when you have any tree which is unbalanced, okay, and having more than one unbalancing factors, then you have to start balancing the tree right from the subtree lowest level. Okay, first start rotate from the lower level. After that, perform it in the upper level if it is unbalanced again. Okay, so that's what we have done here. Now after this, what is the next? We need to insert value 60 in this. So when we insert 60, what will be the tree structure? So compare 60 with 20. 60 is greater, move towards right. Again compare 60 with 40. 60 is greater, move right side. Again compare 60 with 50. 60 is greater, move right side. Now 60 will get inserted to the right of 50. After insertion, now again find the balance factor. Find the balance factor for 60, that is 0. Balance factor for 50, 0 minus 1 minus 1. Balance factor for 30 is 0. Balance factor for 10 is also 0. Now balance factor for 40, 1 minus 2. So minus 1. And balance factor for 20. So here left side 1, right side, what is the height of right subtree for 20? 1, 2, 3. So 1 minus 3. What we will get? 1 minus 3 is minus 2. Now you can see here we have unbalanced, right? So if the tree is unbalanced, now you need to choose which rotation you need to apply based on the tree structure. So if you see the structure of this tree, where we have inserted the new node 60. So after inserting this 60 only, this tree gets what? Unbalanced. So where the height is maximum, the height is maximum in this side. Okay. So what we are doing is we are going to choose 3 nodes starting from this unbalanced node towards this right side. Okay. So I'm going to choose 20, below 20, 40 at the right, and below 40, 50 at the right. Now these 3 nodes are chosen to perform rotation and to perform balancing. Okay, so wherever the balance factor is exceeding the range, start from that node, okay, to perform rotation. And where you have to choose, what you have to choose is actually by inserting which node value we are getting this unbalancing, okay, and that node is at which side, whether left side or right side. So based on that you are going to choose, right? And since it is right side, I have chosen these 3. Now apply rotation. What rotation we can apply? If you choose these 3 nodes, okay, so what is the structure? 20, 40, 50. If you observe, so this is again what? Right skewed. If it is right skewed, we need to apply what rotation? LL rotation. If we apply LL rotation, single left rotation, then what would be the tree structure? 40. This becomes left of 40 and right side is 50. Okay, now in place of these 3, we are going to replace this tree. So here 40, okay, and left of 40 is 20 and then right side 50, right? Now what is at the left of 20? Already in this tree, okay, we have remaining values also like 10, 30, 60. These are all remaining, so we need to place it here in this tree. Coming to 10, 10 is placed in at the left of 20 already. So to the left of 20, place 10 as it is. Okay, and then what is remaining? 30 and 60. Coming to 60, 60 is already at the right of 50. So place 60 to the right of 50. Now coming to 30, 30 is placed at the left of 40. But if you check here in our tree, we already placed 20 as left of 40. So we cannot place 30 here. And what we need to do now? So to the left of 40, again compare 30 with 20. 30 is greater than 20. If it is greater than 20, move towards right. And right side it is empty. So you can place 30 to the right of 20. This is how you need to place the values, okay, nodes. Now after that, okay, we placed all the node elements. Now we need to find the balance factor, and balance factor for 60 is 0 because leaf node. 30 is also 0, 10 is also 0. Coming to 50, what is the left hand side height? It is 0. What is the right hand side height? 1. So 0 minus 1 minus 1. 20, left side height is 1. 20, right side height is 1. So 1 minus 1, 0. 40, what is the height of left subtree? 2. What is the height of right subtree? 2. 2 minus 2, 0. Now the tree is balanced again. Okay. Now insert 70. Where 70 will get inserted? Compare with 40. It is greater, so move to right. Compare with 50. It is greater, move to right. Compare with 60. Again, it is greater, move to right. Now in this case, so 70 should be placed to the right of 60. So where 70 will get placed? To the right of 60. And here it is as it is, that is 10 and 30. Now again find the balance factor for this. So balance factor for 70 is 0. Balance factor for 10 is 0. For 30, 0. For 20, 1 minus 1, 0. For 60, 0 minus 1, minus 1. For 50, 0 minus 2, minus 2. For 40, 2 minus 3, minus 1. Now where the tree is unbalanced? Here, this node is unbalanced. So from this node, Actually, what is the cause of unbalancing? Inserting 70 is the cause for unbalancing. So from -2, move towards right and take 3 nodes. So 50, 60, 70. Now if you take these 3 nodes, what is the structure? Structure is right skewed. If it is right skewed, what rotation we will apply? Single left rotation. So apply LL rotation, that is single left rotation. If we apply LL rotation, what would be the tree structure? So 40 as it is, keep this left side as it is, that is 20, 10 and 30. Now coming to the right side, if we apply rotation, left rotation, 50 becomes the left child of 60. So 60 will be the root node now for the subtree, and then 50 becomes left child and 70 will be at the right side as usual. Okay, now find the balance factors. Balance factors for 70 is 0. Balance factor for 50, 0. For 30, 0. 10, 0. For 60, 1 minus 1, 0. For 20, 1 minus 1, 0. For 40, 2 minus 2, 0. So the tree is balanced, right? And in the next step, what we will do? In the next step, we will be inserting value 80, which is the last value here. So if we insert 80, where do we insert 80? Which should be at the right of 70. So 50, 70, right hand side 80. And here 10 and 30 as it is. Right? Now find the balance factor. So what is the balance factor for 80? Balance factor for 80 is 0. What is the balance factor for 70? 0 minus 1 minus 1. Balance factor for 50, 0. 30, 0. 10, 0. For 20, 1 minus 1, 0. For 60, 1 minus 2 minus 1. For 40, 2 minus 3 minus 1. Again the tree is balanced. So this is the final AVL tree. So this is what the AVL tree construction for the values from 10 to 80.